Welcome to Lesson 2, Part 3, Video 1 for Chemistry 2. We are talking about different calculations involving solutions and concentration. So this is our third different type of calculation, and in this one we're going to look at dilutions. So we're looking at how, if we add more solvent to a solution, how that affects concentration. So with this, we are adding more solvent. So since water is our universal solvent, if we have a given solution and we add more water, what changes is the volume and the molarity, but one thing does not change if there is something dissolved, and that is the amount of solute. So with a dilution, we are going to decrease the molarity or concentration. It could be percent mass also, but we're changing it. It's decreasing. We're increasing the volume, but the number of moles or the mass of solute does not change. It remains the same because we're not adding more of it. We're not taking any of it away. It's still in there. So if that doesn't change, then we can calculate a new molarity. So this ends up being an inverse relationship. As the volume goes up, the molarity goes down, and it's going to be proportional. So if we know that molarity is equal to moles over liters, we can rearrange this to solve for moles. And we know liters is a volume. So if we know the liters and the molarity of a solution to start with, let's just say molarity times volume, that is equal to moles. But since moles doesn't change, that is going to equal this for the new solution, the one that is diluted. So this is the original. We add more volume, the molarity goes down, but the product of the two stays the same. So that gives us this equation, M1V1 is equal to M2V2. So here we have the original, here we have the diluted. Now the key here with this, and I'm going to put a little star here, since we have volume and we have different units for volume, these have to be the same. So if you're given liters and you want milliliters, you have to change one of them to the other. So let's look at our example problems. What volume of 18.0 molar sulfuric acid is needed to make 1.50 liters of 0.900 molar sulfuric acid solution? So volume, molarity, volume, molarity. V1, M1, so those two are paired. Here is our diluted amounts and concentration. So here is V2 and M2. So all we have to do is put our numbers in and solve for the one variable that's unknown, which is this, V1. So 18.0 molar times V1 is equal to 0.900 molar times 1.50 liters. So to get V1 by itself, we just divide both sides by 18.0 molar, and we get V1 equal to 0.0750 liters of H2SO4. 3 significant figures, because all of our measurements from the problem are 3 significant figures. And we have our unit and what it is. So that is our example problem.